Hello, good morning, everyone. So yes, I am the Victor Costa that we'll see in the presentation. I work at Red Hat only with Ansible. If you guys there in the back cannot hear me very well, please let me know so I can raise my voice. I work at Red Hat only with Ansible as a specialist, and one of my focus is networking. I came from data center, so I've worked with network systems, cloud, Linux, and so on. So also if you have any question that's not specific to network, but I don't know, that goes beyond that to systems or integration with external system, etc., please don't hesitate. The idea is to have this as interactive as possible. So when I go through, if you have any question, just raise your hand and we can go through that. I'm also planning to, I don't know if it's a demo, let's say, but it's not a demo about implementation or showing something that works. I guess for those who were at the Automates this year, here in Netherlands, we saw a demo for F5, but the idea of the demo today is basically to introduce some concepts to take you who are using Ansible to the next level from scripting to automation. By the way, who is using Ansible? Okay. So the first part I will go faster, I would say. So then we can focus more in the use case and the process that I've talked to you. Are you using Ansible for network or network systems or and other things? Okay, cool. That's one of the first time that I hear more network than systems and cloud and other things. Good. All right. By the way, we'll have Ansible Fest first week of October. In this year will be only in the US, but we had the Automates is also one of the reasons why we are not doing the Fest in EMEA, but we are running Automate all over the place in EMEA. Right, just let me, okay. For those who saw the Automates speak, perhaps these questions will resonate for you. You don't need to give me an answer, it's mainly for you to think about if you are not doing Ansible or if you are doing Ansible, if you still have those issues, let's say. So the idea also of the demo is to introduce how to optimize the process behind using Ansible and delivering Ansible and all of this. So the first question is, how long does it take to provision layer 2, layer 3 resource for physical and virtual workloads? It's basically today when you need to have a new load balancer, a new firewall, or a new tenant, how long does it take for you for the virtual and for the physical environment? The other question is, how long does it take to provision new physical and virtual workloads? Perhaps you are not directly involved in that, but how long does it take to get a new VM, for example? How long does it take to provision a new server, basically in the data center? The other question is, what is your average time today spent doing troubleshooting because someone did change something, and then the day after that, someone, meaning the guy who arrives early in the morning, need to go, especially on Monday, need to go through all the list of changes that happened in the weekend to figure out why different things are not working anymore. Does it sound familiar for you? I think so. I used to work in operations also, so that's type of things that I had in my Monday. And the last question is, what are your average time spent with paperwork? When I say paperwork is you need to create a new VLAN or you need to do something, whatever device, firewall, load balancer, switch, router, doesn't matter. Uh, what is the time that you spend going through all the forms, choosing the right options, hopefully, in the forms, so then it will not come back to you, filling all the different pieces to show what is the process that you take to put in place the configuration, how you do to do a rollback or revert. That's also something that we can talk about. And perhaps it's something that will be done by someone else. Then this someone else will just copy and paste the configuration that you put in this amazing form after, I don't know, 2 or 3 meetings to go through and explain why you need it, etc., etc. And then when they do the copy and paste, there is some syntax error because, I don't know, some tabulation or something. And you need to go through this amazing process all over again. And your end user is probably really happy because he was counting on this request or this change to then do something else, because this is one per requirement step for the application they need to deliver. So just think about it. So the reality is that when it comes, and you probably arrive to this same conclusion, is that when it comes to network, the reality is that the way how we manage didn't change that much in the last, I don't know, 30 years. If we establish a parallel between how we do to manage the network and all the efforts that we did in the last, I don't know, 10 years, or even more, we are getting old, around virtualization and around cloud computing and all the automation to get that really quickly available, we are really behind that when it comes to network. And part of this is all the process tools that we do not have or we didn't have so far in network device. So what is Ansible, why Ansible, how you can leverage and use Ansible? The first thing, and that's a common question that I have when I go and I visit customers, especially in the network, is that, hey, I'm not a developer. I don't want to be a developer. That's years away from what I do today. So if you come here and tell me that I need to know or to discover how to code, you just can go back where you came from. So we get back our time. I have some more time to get some coffee or smoke a cigarette or whatever. So yes, you don't need to know how to code to do Ansible and to automate with Ansible. Even if sometimes we say infrastructure as code and code and code and code, we'll go through and we'll see that with Ansible, you don't need to know how to code. If you want to do more advanced stuff, or if you want to develop your own specific model, so then yes, for that piece you need to learn and you need to know how to code. But if you just want to consume automation and to define what is the desired state that you want, you don't need to know how to code. So that's one of the first advantages and reasons why a lot of people are using Ansible, is basically because you can just get in few lines, one day or a few hours, you can start to do something. Even if it's simple as changing a description of an interface or doing some simple tasks, you can just start right away. So you can, and also, Ansible is not there to replace the knowledge that you have, because, or we have in the network, because we are the one who knows what are the steps and required to configure the BGP based on our standard. Do or not the leaking based in our standard, what are the tags, what are all the different things that we do in our network. So that's how you can leverage Ansible, your knowledge and the automation Ansible as a tool to do the automation. So it can be baby steps. So that's, as I said, we don't use the code, we use playbook, which is the way how we describe in Ansible the different tasks that we want to do. And the Ansible will do this in exactly the same order as you described. So it helps you standardize the process, reduce human errors, if you do Ansible in a proper way, and optimize the way how you do your automation in your infrastructure. So as I said, the playbook, we'll see an example afterwards, but basically, let's consider you need to create a new VLAN, or you need to configure a new VLAN for, I don't know, some customers use the cloud pod, so then they see the top of rack switch and the rack itself as an unity. Others, they still refer to device-oriented automation or configuration. Anyway, consider you want to create a VLAN. Regardless if you see this as an unity or if you see each device, the process is still the same. You need to create a VLAN, then after that, you need to add ports to that VLAN, regardless if they are trunk or access. Then you need potentially to create an interface VLAN, so you bring some routing to that particular VLAN. In the playbook, what you describe is exactly this. The first step is that's a difference also. I want to have that VLAN in the device or group of device. The next thing is I want to have that port or that group of ports associated to that VLAN. And the last one is I want to have this interface VLAN with this IP configuration or HSRP, VRRP, doesn't matter. Why I'm using the word I want is because that's one of the difference when you are doing scripting and when you are doing automation with Ansible, is because in Ansible you define what is your desired state. It's up to Ansible and the models to figure out what it has to do to get you to that desired state. Meanwhile, when you do scripting, it's up to you to describe what are the tasks and the things you have to do to get to that desired state. And the difference is that, for example, I want to have that VLAN created. That's what I describe in my playbook. If I'm doing scripting, I need to check if the VLAN is there. Then if the VLAN is not there, I will create and this and that. With Ansible, I can just say, I want the VLAN to be there. If it's there, it will not do anything. If it's not there, it will create the VLAN. Hopefully, it's clear for everyone.
Question.
Yes.
When do you consider your infrastructure ready for this kind of implementation? I mean, it sounds simple, but what do you need to be ready for something like this?
You just need SSH access, what you are already using through CLI, and that's it, basically. And after that, it's just the way how you organize and you scale how you do the automation. Basically, you can have, I don't know, you have 10 different devices in your network, in your data center, or 20, it doesn't matter. You may have 20 playbooks, one for each one. It's not the optimal, but at least you have something that refers to each particular device, or you can have a single playbook that take information that are specific to each particular device. So there are different approaches and strategy, but there is no specific requirements from the device perspective to do Ansible. So there is no need for agent, there is no need for installation of Python or whatever. You just need the SSH and CLI access in the same way as we as humans do. We do SSH, CLI, we send the commands that apply configuration or show commands that get information from the state in that particular device. Hopefully it's clear.
Yes.
So one of the advantages about that is that Ansible only uses text. So the playbooks, they are written in text. It's a standard flat text file. There is no need for any proprietary or specific database. What is the case if you, depending on the solution, you may have the requirement to have a proprietary database, and then once you put the information there, you need to, it's like being with that solution for life. Because if you want to migrate or to move out of that, it becomes really, really complex as all your information, all your data is inside of that particular proprietary database. With Ansible, you only use text files, which also give us another advantage to use source control systems to track and to have different versions of the automation that we do over time. For example, let's say you have an implementation, a playbook or something. Over time, you make it evolve. Perhaps it starts simple, just create VLAN, put interface in a VLAN in a particular interface. Put a particular interface and associate interface to VLAN. Over time, perhaps you start to integrate interface VLAN as well. Perhaps over time, you start to integrate HSRP or VRRP, then integrate OSPF, then integrating other things. The good thing is that as you are using text file, you can store that somewhere. And we really recommend to use a source control system. So then you can track over time the evolution of your automation, and you can also integrate tests. So instead of doing tests in production, finger crossed that it will work as expected, you can do some tests, perhaps creating a virtual environment against which you test, and before that, you do some tests to validate some policies that you may have internally. I don't know. That's a part of the demo and the example that I show. You have some policies for SNMP community, really simple example. The policy may be communities cannot be the same between read-only, read-write. I may have some requirements about the minimum size for read-only, which are not the same for read-write. Then I want to have capital and some other character for the read-write. For read-only, I don't require that. So all these tests you can run using the same tools now that developers use. Again, doesn't mean that you need to be a developer. It's just that we are leveraging what works in the development world and apply that to automation and networking automation. So as soon as you start to use Ansible in the network, you probably have other teams in the organization that are using for systems that are using for cloud and other things. As you start to do that, you will start to talk the same language as the other teams, what really facilitates the reuse of automation among teams. For example, a lot of Linux folks, they start to do automation with shell script or Perl or I don't know what. Then the Windows guys, they are doing with PowerShell or something else. Then perhaps the network folks, they are doing with expect or this type of thing. But at the end of the line, we have an user that wants to have the application. And we don't expect to go to this dear user and say, hey, you run that script in that server, then you run that one in that particular server because it's PowerShell, and then we run that one from that other server. Or you know what, just open 5 tickets. So each particular team will do this in a different time, going through all the change request process, and perhaps in a month, you have something. So if you leverage Ansible, you can reuse each other, what's beneficial for if we see the big picture where you are delivering an application. So what is Ansible? We talk about, most of you already know. So we have 2 pieces as part of Ansible. The first one is Ansible Engine. See this as the executor. You can run Engine from my notebook. I can run Engine from a jump server in the data center. I can run this from whatever server with Python, because the Ansible is written in Python. It requires Python to run, but doesn't mean that the network device needs Python installed or agents installed. Anyway, see this as a tool, automation tool. You can run from whatever place you want. The other piece is the Ansible Tower. What Ansible Tower is, it comes on top of the engine, which is the tool that executes all the playbooks, etc., and helps with all the enterprise requirements like credential management, role-based access control, control of information and data that I have, who can do what, who did what when, and all this type of enterprise requirements. is what we have in Tower that comes on top of Ansible Engine. So see Tower as the automation platform for Ansible. So we have the tool, and we have Tower, which is the automation platform. So another advantage also by using Tower is that you can integrate with external systems. So if you have a portal or, I don't know, something that can interact with your automation, you do not need any access to the server from where you run your Ansible. It can just do REST API calls to Tower, and all the role-based access control, et cetera, will apply to all the requests. Also, with Tower, if you want, you have a Tower CLI, so which is basically, it helps and facilitates the process of doing the REST API calls for the folks that do not like going through a web interface or interface at all. You can use the Tower CLI to trigger automation to do different tasks at Tower. You can also use that to automate Tower itself. So you can automate the deployment of a Tower. So you can populate all the different information that you need. So then you have the entire process automated end-to-end, which is basically the way how I configure Tower and also the way how I run tests of my automation, etc. So why Ansible? There are just 3 simple things. The first one is simple. And why it's simple is that you don't need to be a developer. You don't need to learn how to code. You don't need anything specific. You just get, I don't know, a few examples or something. You start to playing around, and you see that you can really quickly start doing automation. The other reason is that it's powerful, which basically means that you can orchestrate the way how you do the automation. So for example, as you start to create your automation for the network, perhaps the application guys can reuse that to interact with load balancer. So they can integrate as part of their application deployment some activities like I pull out the server from the pool in the load balancer, or I do a rollout upgrade, whatever. All this process can be orchestrated, and you can reuse automation from each other. And the last is exactly the question that you had, is because it's agentless. So there is no need for anything specific to start doing Ansible. And I guess it is as powerful and also linked to simplicity, which is basically you have your switch. You don't need to do any iOS upgrade or image upgrade to have netconf, to then do this, that, to start interact with the device. You do CLI, we do CLI. We just need SSH access, the credentials to log in the device, and that's it. In the case of systems, it's pretty much the same. There is no need for anything specific. In the case of Linux, we will use Python, which is there by default in most of the distributions. In the case of Windows, we use WinRM, which is the SSH-like for Windows. So there is nothing specific. There is no need to go through the security pane where you need to justify why you install the agent, what are all the flows, where the information goes, where the information comes from, et cetera, et cetera. It's just a standard process that you are doing today. Any questions?
Well, you keep repeating that there is no coding skills needed, but I've been working with Ansible a little bit, particularly Jinja.
Yes.
Is coding to me.
Yes, that's why when I say there is no need for code, is if you use the models that you have to push the configurations to the device. As soon as you start to do Jinja templating, yes, you start to need some coding skills to go through the process of validation of variables and ifs and fors and loops and all of that. I'm not a big fan. I would say there are 2 schools of Ansible. I have a colleague which really likes using Jinja. I'm not a big fan of using Jinja because perhaps it's simple at the beginning, but as soon as you start to integrate more and more configuration, it grows. And then when you look at that, you say, perhaps I'll go and do myself in the command line so I really know what I'm doing. There are two schools.
You also automate, you want to extract information from a form or from variables, and
Yeah,
then you need the Jinja.
well, you still can use just iOS config and the variables on it and the tasks, so you have something that's more readable than a big Jinja that do all the templating. I would say that I did some Jinja, but what I try to do is that I decouple. So for example, I do not have a big Jinja file, which is my gold master that will do all the magic configuration, but different piece for interface. So I have my Jinja that only applies to interface. And
You
so
already need Jinja if you need an integer as input for a module. Then
If
you
you-
already need Jinja because the templates only use text string variables. So you already need.
you need Jinja for what, sorry?
If I use tower and I input a variable,
Yes.
it's always a string
Yes.
for Ansible.
Yes.
If my module requires an integer,
Yes.
then I already need some Jinja code to translate.
You can do asserts. You can have a standard assert task, which is assert that this variable is iterable. Or assert, I can show you that. Assert that this variable is defined. Assert that this variable is a string. Or you can go even further and have this as a role. In the role, you define what are the spec of the role, which are basically what are the values that you are expecting, what is the type, string, array, etc., etc. And then when someone calls that role, if they do not provide the right spec, you just fail in that particular spec, which is not good. I can show you an example if you want. Good question, thank you.
Yeah.
But yes, if you go through the Jinja path, you need to be some sort of coding, but you can do only tasks, standard tasks, in using the modules that are available for you. It's a two schools, I would say. Yes?
I have another question. About Ansible coverage of the hardware. So, for example, there are multiple manufacturers, right? So, Cisco, Juniper, etc. So, you need to have models implemented to run, for example, create a VLAN because it's completely different one. And even within the same brand, you have, for example, Brocade router series and you have Brocade L3 switches series. And for example, there creating a PBR rule is completely different. So from this light point of view, it's different. So do you have, for example, a list of supported devices? And is it possible, for example, through from a playbook, I want to create a VLAN, and then on this group of devices, which are like from different brands, series, etc.
Yeah.
So how is it handled?
Okay, so if I rephrase the question, it's basically how do I do to have agnostic implementation of automation?
Exactly.
So you have different layers in Ansible. You have the model, which is the unity to do a specific activity, let's say. But you also have roles. And the advantage of role is that you create an abstraction layer between that only model and what you want to do. So for example, create VLAN, I can create a playbook with the different tasks. So then I will go through, I don't know, all the process of checking, is it Arista, is it Cisco, is it iOS, is this, that.
So, excuse me, it's not handled automatically. So if I say create VLAN, then on Cisco and Juniper, I need to, in the playbook, I need to identify. So if Cisco I want to do this, if Juniper I want to do this, or how is it?
No, what you can do is, you can do this way, which is the easiest way for those that are starting with Ansible, is you do a check, you have the tasks that you want to do, and then you just run it. Or you can start to make it more scalable, which is you start to introduce roles. So you have a role which is create VLAN. You have a role which is create VLAN Cisco, create VLAN this and that and that and that. And then at the device you say, this device is a Cisco iOS. So then when you call create VLAN, it will use that device information to know, oh, it's an iOS. Okay, so I will call the iOS create VLAN. Oh, this one is Arista, so I'll call the Arista create VLAN. That's the direction that we are taking with Ansible for networking, where we start to deliver roles which provide more value on top of the tasks and the models.
Okay, that's fine, but in the underlying layer,
Mm-hmm.
for example, even within Cisco's like iOSs between like this, different versions of iOS, you can have so how many devices supported by Ansible by these models and their models?
Well, whatever model that you see in the list of models for Ansible, you can consume. It's just the way how you consume. So if you want to run something that's really, really agnostic, you probably take netconf, so you don't even bother about what are the different pieces of data that I need to provide depending on the device or the platform that I'm using. I don't know. Cisco, when I'm doing VXLAN, I need to provide VNI. Juniper, I don't know what I need to provide. In Arista, I don't know what I need to provide. If I want to standardize this, then I need to take a netconf and probably OpenConfig, which is a standard format data model to feed and push to my device. The other path is, well, I don't want to do this because I have a lot of legacy device that I will not go through this process. So I can do this agnosticity at Ansible level, but I need to create the layers to abstract from the model that do the config for iOS and the config for each particular platform to something that will figure out what is the platform and call the proper group of automation for that platform. That's the direction that we are taking also with the Ansible networking, is to start delivering roles that are agnostic, that comes on top of other roles that are device specific. So then it simplifies all this process of what I want to do, what I call, and I just want to have the job done. I don't want to do this myself. So yes, we saw that. So with Tower and the external and the REST APIs and the role-based access control, etc., it's mainly API driven. So you can have this as the automation layer between the network, systems, cloud, etc. So it also simplifies how external systems will consume automation. So if we try to see a big picture, it's pretty much like having an abstraction layer between my infrastructure components and the different automation that I want to do. And when you see these names here, like BGP, load balancer, SPF, etc., see those as roles. So you have a role which is responsible for BGP configuration. And then when you want to do BGP, you call that role. We'll go through what's the role, by the way. You call that, and you feed the data. So that role will take in charge the process to do the configuration based on what is the desired state you want, and for VLAN and so on. So also another comment is that we are not in the data paths at all. We do not change the way how the different network device work. We are just doing automation. So we call, we put in place, and we ensure the desired state. So if someone goes and connects through CLI and breaks something through CLI, it's not something that Ansible will figure out automatically that, well, somebody did change something, I need to put this back in place, etc. That being said, you can enforce saying, I will run my automation every X, or I have some event-based automation. Someone did change something through the command line. It triggers something in my monitoring system. It calls Ansible. Ansible ensures to put back in place the configuration. So there are these are just few steps. You can do them in parallel. You can do this in sequential order, which is basically you standardize the way. I guess this is pretty much okay for us in the network, because when you go through the design, the architecture of a network, we establish a standard just before, or we should, just before putting in place all the devices and the connectivity between them. We define which roles we have. This is a spine, this is a leaf, or this is a aggregation, this is access, this is core, and so on and so forth. I have those ports with this configuration. We have standards, or we should. That's different when we come from system where you may do pretty much whatever you want. So as we have those standards, we can also start to automate and doing chains and push chains that will consume and use those standards. For example, I know most of the times for my device in data center 1, I will use a specific TACAC server or a group of servers. Perhaps it's not the same as my data center 2. All these standards I can automate with Ansible. It's a really simple, quickly automation that I can do. ACLs, it's most of the times also standardized. You have the management ACL that applies to the management interface. You have a group of subnets, etc. So when you create a network, it's there. But over time, perhaps you need to add a new subnet. And then you have hundreds of devices that you need to go through to just add that ACL for that new subnet because, I don't know, you do not have more, or you have a new location, a new VRF, for whatever reason. So those are all simple automations that we can also do with Ansible. SNMP rotation, to rotate my communities, my SNMP read-write communities, and all this type of thing. And the scalability, it comes when you start doing automation. You probably do this from your notebook or from a jump server in the data center. You install Ansible, have Python, you just start doing this. But as soon as you start to go through, I have hundreds or thousands of devices that I want to automate. And I want to perhaps publish some of the automation that I did to be consumed by other teams. So the application can do some specific load balancer tasks and all these type of things. That's where you start to see more and more the need of tower or an automation platform. All right. Any questions? If you have questions, just don't be shy. So we go through more in details about Ansible automation for networking. So this is how you should be doing Ansible for networking. It also applies for standard Linux, etc. You segregate the layers. Most of you start with the variables defined in the playbook itself. It's okay. It's a quick way to start doing this. But as soon as you start to scale, you have different devices in different locations with different roles that do not have the same values of variables that will apply to them. Example, DNS data center 1 is not the same as my data center 2. And then what you do a copy and paste of the playbook, so you have DNS data center 1, DNS data center 2, just because you need to change the variables. And then you need to add a new task on top of that DNS change. So we have 2 files. So you have 10 sites, you have 10 files, you need to update. So it starts to become really, so all the automation that you start simple, it starts to become really complex and also to execute and maintain. So by decouple these, you have the definition which goes in the inventory. So you have different places where you can define Ansible variables. You can define in the playbook itself. You can have a file with the variables and values, or you can put the variables in the inventory. That's the way how I do personally, and I like to do, is have the values and the variables at the inventory level. So at another level, I have the implementation, which is basically the roles or the different playbooks that I have. So instead of having my 10 different DNS config playbook, I have my DNS config playbook which will take the variables, and the values of the variables will depend of where the device is. So this information comes from the inventory. Is it clear for everyone? Yes? No? Yes?
So could you elaborate a little bit more on the variables? So you're, as you're saying, you put it in the inventory file, but on the top of my head, there is a hierarchy which
Yes.
also is followed.
Mm-hmm.
And if I have a row, let's say, which I'm downloading from Galaxy or some other place,
Mm-hmm.
like sometimes my problem is that when I do that, I have to like dig through everything to understand what should I be doing with this row.
Yeah.
Is there an easier way? My question more is like, is there an easier way to some trick?
Yes, the easiest way is you proper create roles and you proper create specs. And you, so far, what you had to do is you had to cross the fingers and hope that someone did put all the variables in a README file and describe what each variable is doing. But that do not force the one who is doing the implementation to document, because perhaps, I don't know, if they put there or if they do not put, it do not change the automation. It will not break the automation. It will break who is consuming the automation, that will start scratching the head and, okay, I need to go through all the tasks and everything to figure out all the variables.
Right.
So the proper way is you create a spec file. Okay, perhaps I will show you this. Just let me. Let's see the. Yeah. So create a spec file where you specify what are the different arguments required by your role, what are the default value that this variable will take, what are the options, because perhaps sometimes you are expecting two values. It can be leaf or spine, it cannot be blah blah. If someone types blah blah, it stops at the spec validation. So it removes all the burden of when at the playbook level. Before even calling, you validate if your spec is being in compliance by the one who is calling the role. So also it helps us who are consuming, so we have, even if the documentation is not up to date or properly done, we know that if we go to the spec, that's what the role is using to do the automation. So that's also a source of documentation. So we have a single place to go.
Victor, how is this enforced then? So I see it written down, but
Yeah, so then at the task level, the first thing you do, you call your thing to validate the spec. This is the type of things that we are doing and that we'll start to deliver with the roles that will come from us. So we start to have this type of implementation that's simple. It's pretty much like I have a system, the system has an API, and I have no documentation to use the API. So that's the way how we are working to tackle that specific situation, which you can also do yourself. You have a file with a spec, you go through that file, you do some assert today just to validate the type and the data that they are providing to you. Yeah. Okay, go.
You just said you put most of your variables in an inventory file.
Mhm.
Is there a reason you don't use group variables or host variables?
Yes, I do. I'll go through that in a minute.
Okay.
So if you like to test this in the pipeline, would you use like Ansible, I don't know, comment to check the rules that you included? Like Ansible lint, that's an
I will go through that as part of the demo.
Okay, cool.
So I will. So you were saying, sorry.
If you're using group variables or host
Oh
variables,
yes,
so why
yes,
not?
yes. So the question is, I said that I'm using inventory to provide variables and value, but then how do we do with the inventory? So there is a. So did anybody get this? You have your variables and values, and you have your implementation. You are the guys that will do the implementation. The application guys will be the guys that will consume your implementation by providing this. So if you see the big picture, just before going to the group variables, etc., it's like this. You have something that from where you have network, you have application, etc. Then you organize that in groups. So you have a load balancer, a firewall, router, etc., etc. Then you have specs that you apply to particular groups. Then your implementation will consume those specs. And your user, what he does is that he just calls the different implementation. So that changed from I have a dual playbook with 200 tasks on it, from I start to standardize and I start to make my automation in a way that I can scale. So if we consider your question about group vars, host vars, etc. So as soon as you define what are the groups, you can start to define the specs for that group level. So for example, let's say I have an application, so I have a group for my application, which is my application. Then I can put all these values, spec for my application at the group level that applies to my application. So whatever my application consumes, it will know what it has to do at the web, it will know what it has to do at DB, it will know what are the rules that my application need, what are all the different VMs and stuff that my application needs. So that's how, what you do, you make it consumable by others and differ from, I have a playbook just to execute some scripting automation. There is nothing wrong in doing this. It's just that you go through levels and you evolve. Does it answer your question about group vars and host vars?
Yeah, well, the question was mostly because you said inventory file. If you like, what's the reason you don't use group vars, but you do?
Yes, I do. I do use. I can show you.
Question is answered.
Okay, the common structure that I use is. Well, I will go through this as part of the demo. But the approach is to have a repo that represents my inventory. Why? Because by doing so, I have versioning, and I can do tests for all the change. So the change is not in my playbook. My playbook is the implementation, is what will put in place the automation. The change is in the reference and the data that are consumed by my implementation. Does it make sense? Yes?
Question, how does this work with Ansible Tower? Because the inventory is normally lives within the playbook project.
Well, you can have in Tower inventory that is actually a Git repo.
Yeah. Okay. So the project, so you have a different project that defines this role, or this Git repository.
Yes.
As the inventory for your
Yes.
other project.
Yes. So then another thing that I can do is that based on this, and that's what I did previously, for all the changes, they come as pull requests to change the data. Then I can run all the tests that I need before even touching any device. So the linting question or the question about the policy, SNMP policy and all of that, I can run against my data and not as part of my implementation. The implementation is the next step, just to make sure that I have in place what I was expecting to have in place. Let's say I'm doing OSPF configuration. Yes, Ansible will ensure that you apply the configuration. So you have your OSPF instance, you have your interface associated with the OSPF and so on and so forth. But perhaps you put a password in the device 1, which is not the same as the device 2. That's not the type of thing that you can test through linting or only data validation. You need to deploy something to check if the neighbor, OSPF neighbor, is up, to validate that it's actually working and will not break when you apply that in production. So we'll go through that afterwards. So the implementation, so you have a source of information, which we call source of truth, which are basically variables and values. You have an implementation, which are the roles and the implementations that we as network experts will do. And those together will define what are the infrastructure and what are the resources that we are deploying and the configuration we have applied to the device. Does it make sense for everyone? Sorry, it's a little advanced for those who didn't know Ansible, so don't be shy. If you don't get something, just raise your hand and then we can go through that. So we saw this, and the good thing is that as we are going through Ansible at different teams, different levels, as user, I have a common format to describe what I want from the different components of my infrastructure. It's not I run a script in the server 1, another in server 2, and so on, or someone else will do. I can just provide what are my application specs, and the implementation from the different teams will take that and put in place. So yeah, it's not really big. The thing that you need to consider that is, I guess, as important as the implementation is what we call the data model, meaning what is the structure and the variables names and the way how we'll define that. So then when we start to implement the roles, we have the variables and the values that we are expecting. So it will not fail when going through the spec validation. So if it's pretty much like API, I have an API, someone needs to document and create a spec for the API. I have a microservice or something that will implement that and do something. And then as output, it will provide the data. In our case, we provide infrastructure and we provide infrastructure components or configurations in place. Someone had, yeah?
Just the idea of combining the inventory with the variables in one definition file.
Mm-hmm.
I didn't get what the benefit. Why don't we still define the inventory as what host will receive this automation away from what variables will be applied? So you mentioned it's combined in one definition file. So inventory includes variables as well as the hosts, right?
Yeah, it includes variables, and the variables they apply either to hosts, meaning device. So those are values that are specific to each particular device. Or they apply to a group, which is actually a group of device. So for example, data center 1 is my group. Spine is another group. Spine 01-data center 1 is the device. I can do my automation as a device-centric, which is basically I go device per device and I specify what are the values that will apply to each particular device. Or I can do this as a functional level, spines, I want to do something to all the spines, or I apply this to location level. Let's say I want to do something to all the device in a particular location.
But you see, having the variables in the same definition file as the inventory is a benefit than having it separate.
What do you mean? What do you mean by having separate?
I mean, we could have completely different files, one for variables and one for the inventory costs, right?
Yes, you can do this. There is nothing wrong. It's just that over time it becomes complex to manage because you have a variable file for data center 1, then you have a variable file for data center 2, and so on and so forth. And you need to call and know what is the variable file that you call for your playbook, and all of these things together make it more complex than I have a single place where I go. I have a structure that I go and the place where I put my variable. So whatever happens, I know exactly the place where I can go. Other than perhaps I have a variable file that is with my playbook, but it's calling a variable that is in another place. It can become really messy over time. So the idea of a source of truth is I have a single location to go, which can be what we see here. I can also combine. For example, I can have this inventory here, which is in my Git or stuff, that I can combine with data coming from public cloud or with data coming from my ITSM system. So I may have some data that comes from my ITSM system, I don't know, ServiceNow or something, and other data that are really specific to what I'm doing that come from the Git. So for example, the device, the list of device, and the way how I do to connect to each particular device. It can come from my ITSM, but what are all the different configurations that I do to do BGP, to do OSPF, and this and that? It comes from my Git. The benefit is that if I over time change what is the configuration that I want to apply for BGP, I will have the track in my source control system, Git, of all the values changed, and I can also test that before applying to any particular device. So another, that's tied to data model. As soon as we start to take this path, we think less about the implementation, because the implementation, we know what we have to do the configuration of OSPF or this or that. It's more about, okay, what are the data that we need to do this particular configuration or that particular configuration. That's where I spend most of my time, because the implementation afterwards is just, I need to do this, that. I know the values, what I expect in each particular variable and the values, so I can easily do the implementation. The advantage of Ansible as well is that you can use whatever model that you want, so you don't need to be tied to one particular specific model. As we saw, you can organize and structure in whatever way you want. You can also use some existing model that are start to see more and more. For example, customers willing to use OpenConfig as the model, data model for configuration. So whatever OpenConfig interface, OpenConfig BGP, etc., it's basically a definition of variables and the values that are expected by each variable that will push to the device. Pretty much like, I don't know, we had with SNMP, sort of. You can use your own, but you also have some that are custom specific or that are vendor specific, actually. So for example, I don't know, you do not have all the data models available in OpenConfig, but you have some that are specific to Cisco, other that will be specific to Juniper, and so on and so forth. So it's up to you to, do I want to use that, or do I want to then create my own model, so then I have more agnosticity? There is pros and cons Perhaps you lose some features that are specific to one vendor that you do not have in another. It's based on what is your automation strategy, actually. Then, when you have a model, we do encoding, which is basically, do we take this model, do we send through CLI, which is exactly the same as what we do as human, and we go and we connect and we send the commands and the configurations. Do we create a format like JSON, or do we encode as XML, for example, which is mainly for netconf? So netconf, you need to take the variables and values, apply the model to validate that you have the proper values, etc., and then you push that to the device. It could be in JSON. It's mostly used for APIs. So F5, for example, they provide an API. You use basically REST to establish a communication, send your configuration. For legacy device, it's mainly based on CLI, SSH. You connect, you send your configuration. So you have the freedom to use whatever is best for you and what is available also in each particular platform. So API is also used, for example, when you need to integrate with controllers, ACI, for example. You need to integrate with Cisco ACI. So you do API calls. We have models to communicate with Cisco ACI. Or other controllers over time, you may have models for that as well. Meraki, I don't know. The thing is that you are not tied with only one single particular format that you need to adhere. You have the freedom to do in whatever way is best, depending on the platform, depending on the context, depending on the environment, and so on. That's one of the main differences. We don't expect that customers will need to upgrade all the images of routers and switches to do Ansible. He can do CLI for all the legacy stuff. For all the new stuff, perhaps they want to do netconf, Yang, or something. We also provide that. That also helps with, he's not there anymore, with the agnosticity about, well, the different platforms. That's what this guy promises, is to have something that is agnostic for the transport. But remember, you still have this. So even if you have netconf, which is a standard way to communicate, you may have different data modeling. So do not expect to have this great VLAN that applies to Cisco that will also apply to Arista and so on, because their data model are potentially different. That's why I have this open config thing. That is an effort to standardize this modeling. So create VLAN is the same among platforms. So we have more than 45 platforms, 630 models. You have everything on it. It's only for network. We are not considering cloud or system or anything else. This is the evolution over time. We start with like 7 platforms, 28 models. And we are with 45 platforms and more than 630 models. It's something that we are getting a lot of requests and a lot of things and work to do. Is, as we saw, basically the network we are lagging behind actually. For different reasons, we are lagging behind in comparison with virtualization, compute, and all of that. There is no magic solution. This is just it's not extensive, but an example of modules and platforms actually that you can communicate, interact with using Ansible. So basically, netconf, as I said, whatever platform support netconf, you can use it. You have the different platforms for Cisco, like ACI, which is not really a platform control, but anyway. NXOS, iOS XR. We have modules for NSO as well. I had some customers that were using NSO. And they wanted to expand what NSO was doing with Ansible without going into details. You may have Juniper. You may have also Infoblocks or some sort of IPAM that you need to interact with to get what is the next IP available. You know that little Excel. I'd say that so far the CMDB for network is an Excel spreadsheet somewhere, right? In a shared location that hopefully the guy who opened it, he closed it and saved before going vacation, right? So we can know what is the next IP available and all these sorts of things. So yes, you can use, for example, Infoblocks as a dynamic inventory. So that we have some customers doing this is that everything is registered in Infoblocks regarding management, etc. So they take that as the source of truth to combine with the different information that they may have to do the implementation. Also because nobody trusts ITSM CMDB, right? Oh, the device is still there. Oh, we just removed this, I don't know, 2 years ago. Oh, really? Oh, this one is not under contract anymore. Oh, really? Oh, it's still under production? Is in the floor of the VP? And by the way, we have no backups. We need to think about it. Sound familiar for everyone? So the path we are taking with the Ansible network and the automation and the roles and all of that is we have, the thing is that with Ansible, the upstream, the project, we have the life cycle of release and patch and all of that, that sometimes it's not fast enough for us because we have new platforms, we have new models, we have bugs, we have things that we are fixing and so on. And we need to wait for the next release and all of that. So instead to optimize all of this, we start to deliver more and more roles. So this implementation of models, etc., will stay in the Ansible, but on top of that, we'll start to have roles for specific tasks and activities. So for example, consider here in the bottom the models and the connections. So basically, what is the Ansible project? So all the things to manage SSH connectivity or API to NX API and all of that will be part of the project. But on top, we start to have more things, for example, the network engine, that are focused on configuration and operations. So I want to load a config. I want to get a config. I want to do something. And all of that, it will use the models, but it's like creating abstraction layers. And on the top, it will be pretty much network functions for the different things that we may want to do. That can be device-centric. I want to create a VLAN in a particular device. I want to do something in a particular device. Can be application-centric. My application wants to have a new load balancer configured. Or can be cloud-centric. Well, I want to have a multi-site VPN from my different clouds. So for example, we'll go through that afterwards in the use case. Anyway, this is the path, this is the direction that we are taking, which also give us more freedom to release this without waiting for the upstream and the project. And also helps customers to consume simpler Ansible. So you go here in the bottom, it's more developer focused. I want to develop a model. I want to develop something to integrate with a specific system, etc. More we move to the top, more we abstract that. Any questions so far? So the other thing is just a comment about the difference when you are doing Ansible for systems and for network. As I said, For network, there is no requirement to install Python or whatever device. For Linux, it will use Python that's already deployed, available at the device. There is also another difference, which is, consider the control node the machine from where you execute Ansible. In the case of systems, what Ansible does is that it will create a file, it will copy the file with the different automation to the server, and will execute in the server. And then it will have the communication to have the outputs and all of that. In the case of network, we cannot create a file, copy the file to the network device and run from there. So what we do is that everything runs from the control node, and what we send to the device back and forth are the commands in the same way as we do when you are in the CLI, or API if we are using API to the device, or netconf if we are using netconf to interact with the device. Most of the time over SSH. All the different components that we have in Ansible basically is you have your playbook. When you run the playbook, it will get the inventory to know what are the different variables, device, how to connect to the device, and all of that. You may have models that are from the core, Ansible core, that are from network team, or that are from community, or your own. You have the plugins if you need to interact with, let's say, info blocks to get next IP. The next IP, it's not a task where you go to describe. It's pretty much, I want to have the next IP associated to a var. So then in my automation, I just refer to that var that I know that's next available IP. Or the next available subnet, yes.
How plugin is different from module?
The plugin here, it will mainly apply to associate values to variables. The model, it will actually execute some activity. The plugin is basically, I need to interact with something external, or I need to do something that is not done in the remote device. It's done locally. For example, I want to validate that a subnet given by a user is valid. Or I want to validate if an IP given by a user is part of a subnet. That's not something that you want to execute at the device and, hey, no, well, syntax error and this and that. It's something that you want to verify locally, so perhaps you create a plugin for that. We already have plugins for that.
So as an example, if I'm doing a compliance check towards a network device, that is expected to be a plugin, because I will be reading some configuration, execute local checks on the control node. Is that a plugin or a module? Or does it matter?
It can be a model, it can be a plugin. For example, you can have a plugin to parse the configuration. Or you can have a model that get the config and parse the configuration and give you as an output a parsed information. So everything depends on exactly what you want to achieve and how you want to achieve that. But see plugins as extensions that will associate basically values to variables. You don't expect to execute anything in the remote, but you want to validate variables or you want to associate a value to a variable. Then you have the CLI, which is the CLI. And the big picture is we have data that comes from our CMDB or from a cloud, facts that populates the inventory. The models consume that, or our implementation, our playbook and definition using models, the plugins and so on. Applied will put in place what is the desired state for host, network, or cloud through the different models that we have. It's the same. So a quick example of playbook is To configure NTP is a simple example where you have vars, baby steps, you are starting to do Ansible. You have vars that are defined in the playbook. You have 2 tasks. Here in the top, you have the definition of hosts against which you play and execute that. Here, basically, what we have is 2 NTP servers and 2 tasks. One to ensure that we have the NTP feature enabled at the NXOS, and another one that we ensure we have the NTP servers configured. So when we run, we have two colors. One is green and another one is orange. The green is because those 2 devices already had NTP enabled. So idempotency, I have nothing to do. It's already in place. For the second task, you also see that what we see here is exactly what we put here in name. So name is mainly for documentation. So you know for each particular task what it does, and when you execute, you have in the output, you know where you are, what you are doing. So blah blah or it just do things do not help very much when you execute, or nothing do not help as well. So the orange, it's because this particular NTP server was not configured in the 2 device. So Ansible did a change to put that in place. Important to note as well, you can run Ansible in 2 modes. One is run, which is basically, it will take what's there and ensure that you are in the desired state, or the device or the configuration are in the desired state. But you can also run in check mode. And the check mode is, it will say, well, that's what I would change if I was running in run mode. What sometimes help with compliance. So you have your standards, your variables, your definition. If you have any orange, is because basically someone did change something, so you're not in compliance. You can have this as an information to just know what you are in compliance or not. Or you can just always run in run mode. So I don't care if anybody changed it directly in the device. He should not. It will break, but then lesson learned, he should not go and change directly in the device. Use case. The first one is zero-touch provisioning. We had this a lot in servers world, where you have bare metal, have physical servers, you have the tools and things in place to provide the image to the server and to provision and configure the server. You can also do this with Ansible, which is you have your DHCP server that provides the image. When your device boots, it takes the image and information through the management interface. It calls tower. Tower goes and configure that particular device to perhaps integrate a new device in a fabric, a new spine, a new leaf. It can also apply to Robo, remote office, branch office, where you have some standard. When someone goes on site and put the device, it boot, get the configuration, talk with this data center or the central location to have configuration applied. I saw one customer or 2 doing this for Robo, remote office, branch office. The other use, yes?
So how the device exactly is going to call tower? And I'm just using the engine without tower. Is that still possible?
No, because you do not have the REST API calls to call back, saying, hey, I'm alive, come and configure me. You can only basically do that if you have a REST, because otherwise you need to install Ansible in the device, right? Because as part of your ending process, you execute something at the device itself. The easiest way is you have a system like Tower, You call, say, hey, I'm alive, come and configure me, and then tower, okay, we'll go and configure that particular device.
That would be through the initial config file pushed by the...
It can be your automation and the definitions that you have, it will apply to that device. Let's say that device is in your inventory associated to leaf group. So it will heritate, you got it. It will get all the configuration that apply to leaf, because that's part of your automation. Or if you associate that device, I don't know, to spine, so then all the automation applied to spine will come, then the automation that applies to data center 1, I don't know, will come, and so on and so forth. So you roll out all the different automation that you have to have that particular device in the desired state. So the other use case is what I call a network snapshot. It's different from backup. Perhaps you are doing backup, hopefully, right, for the device that we know. But that probably go to FTP server. Sorry. That goes to an FTP server, and that's it. You have a file in an FTP server, but you don't know what changed from yesterday to today, or from the different times when you run the backup. So the idea is to use Git to host all the configurations. So then in Git you have all these diff natively, because that's how developers they do to do code review, to do all the review of changes and validate code. It's based on text file. I can show you. It's a network config, I guess. Yeah. So here what I did is, for every backup I run, I create a branch with a timestamp, and then every time it runs, it stores that other config. What gives me this, for example, in master, I can see the history of all the changes applied to that particular file. I can see what was the last change applied to that particular file. I don't need to go through all my change requests, who did change what. Perhaps, hopefully, everything was in the change request, right, and documented. So I have this, or I can compare between, I don't know, the snapshot, let's say, that I took that particular date. I can compare against another snapshot. So it shows me between that and that particular timestamp, all the backups that I did in between, what were the changes. So if I take another one.
So what's the reason you choose the branch instead of tag?
It's just because branch, when you go through, you have different devices that will host the configuration and send the configuration. It's not a one-shot operation. Perhaps you have device that will execute faster than others, etc. If you create a tag straight away, a tag is not supposed to change.
No. So you have like multiple commits?
Yes. For each device, he's doing his own commit. And then if I compare those two, I can see that I changed the interface and I changed the banner anyway. Perhaps this strategy of having 200 branches will not scale, but you got the idea. I have different ways of doing this.
Well, afterwards, I can always change the branch to a tag and discard
Yes,
the
exactly.
old branches, right?
Yes, exactly. You can create a week tag, for example, where you take all the snapshots from that particular point in time, so we have the history that we went through. Exactly. The good thing is you have something that you can go in. Did anybody change something? No. And they start walking out the door, right? So you can easily go and see what changed, etc. The other use case is edge automation for those that are moving more and more to virtualization or network functions virtualization. Basically, you can deploy the infrastructure, you can create the virtual instance, and you can apply the configuration to the virtual instance. It's pretty much like a server. That's what we do with a server. You can pretty much do the same with virtual instance, network instance. And you can also prepare the physical topology that you may have. So I don't know, a new tenant, you have a new VLAN, VNI. If you create only in the virtual environment, there is no meaning. So perhaps you have some interactions at the physical top of rack as well, and all of this. This another use case that I start to see more and more, which is CI/CD applied to network, where I want to validate all my configurations. I want to test this in a virtual environment before applying to production. Yes, you probably do not have today all the images of all the devices available to run as virtual instance, but at least it's much better than having nothing and just hope and to go through change. You can do this in public cloud. You can do this on premises with your own image from the vendors. You can do this on top of, I don't know, OpenStack. You can do this on top of bare metal, KVM, Red Hat, virtualization. There are different ways of doing this. The good thing is that you can build that with Ansible, the topology, and also do the validation. End-to-end automation, when you start to reuse and deliver automation among teams, so they can reuse and do the end-to-end automation. So for example, we don't need to be on Saturday night in a conf call just to remove a server from the load balancer. Then we have our folks from operating system, our dear friends from middleware, our friends from monitoring, and we are all happy together in the conf call to do one single task. So if you start to implement and publish in Tower, you can specify who can do what with the automation that you did, and then they have also a perimeter to execute that automation. So all the steps that we see here, which are, I need to stop the monitoring, I need to remove from load balancing, I need to stop the services, I need to deploy my application and do that in a reverse order to have my application back. The different teams, they can publish and provide the automation. So as an application owner, I can go and do that myself. Or even better, I can integrate that in my application spec, and I just deploy my application again. And those steps is a rollout upgrade where I have new servers deployed, I validate, and I decommission my old servers. So there are different ways, but you can only achieve that level if you have some automation that can be consumed by others. Otherwise, you're still tied to incident, someone needs to connect, someone needs to do something because he's the only team who knows where the script is and what is the magic Excel file that describes the management interface of the device. The other use case is closed loop, which is basically I have my monitoring system or my log analysis system. It could be Splunk, it could be Kibana, it could be my Nagios, doesn't matter. I have something that is in charge of monitoring. When an event happens, I trigger the alarm, and I trigger an action in Tower. The action can be simple as just go and collect the logs and attach the logs to the incident ticket. So the guy who will start doing the troubleshooting, he has all the information straight away to do the troubleshooting. Or I can go even further, which is, well, instead of doing knowledge-based web page that nobody goes, nobody cares, and nobody updates, right? Because, well, over time you copy-paste, copy-paste not work anymore, nobody updates, so I don't use it anymore. You can do a knowledge-based for automation, because basically you know what are the steps that you do to solve that particular issue. So if you can pretty much create a playbook to try to solve that particular issue, and then it can be something that is triggered automatically based on the different events that you have from your monitoring system, or you can just have this as a source of automation that the level 1 can try to execute. The level 1 execute, it fixed it, all good. Did not fix, it escalates to level 2. The level 2 is not there basically to just be a firefighter. He's there to understand why it did not work and amend the automation, sorry. So the next time it will consider that corner case, or it will become a new fix for this particular issue. And the good thing is that as you iterate through this over time, you can start to increase your confidence and have events that trigger and try to fix automatically the known issues. The other use case is the joy of troubleshooting. Someone calls you or send an email or open a ticket incident saying, my application cannot connect to the database. Yes, so, well, we cannot connect to the database. Can you give me some information? Yes, it's a MySQL. No, I mean, give me the source IP, the destination IP. Oh, okay. Then you have that data, and the folk is in the phone saying, well, so, what is it? God. For you, it's a source and destination. For me, I have switches in between, I have firewalls in between, I have perhaps load balancers, routers, VRF leaking. I need to go through all of that. So give me some time, and it come back to you. So the troubleshooting automation is basically you need to go device one by one, doing some commands, show IPARP, MAC address table, and this and that. All of these, if you know what are the commands, you can automate and have all this information in a single location. So it at least helps you to accelerate the troubleshooting and the resolution. The next step could be I parse this data so I can figure out what are the different issues that I have. Service chain automation is I need to provision a new tenant. What is a tenant? What is the service that I want to deliver? So perhaps I have actions that are at the top of rack or at the virtual switch. So you can automate all of that, like, create a VLAN at my top of racks, SVIs somewhere, create a new context in my firewall, or if I'm taking the virtualization, network virtualization path, perhaps it's a new instance of a firewall that I will deploy in my network pod. Then put the configuration, then do my peering. So I have the entire process automated to deliver that particular service for a tenant. The good thing is that it may apply to physical and virtual network device. What's not the case for most of the things that are today only cloud driven. They only consider, yes, you can click, but it will only do the virtual stuff. All the physical, well, it's not my problem. It's a network team problem. So you can go through that if you have physical firewall, if you have instances that are shared or not. The other use case is fabric automation, which is basically, I have a role for this, by the way, which is basically, what is a fabric? It's made of spines, leaves, links between them, and some magic that happens. You have some proprietary magic that we don't know if it's using some open protocols that actually are not really proprietary, but we cannot log to the device anymore, right? We enable that feature, and tada, we cannot log, we cannot check it anymore. And also I'm tied to that particular vendor. Another approach is, what is a fabric? A fabric is, I have a loopback interface in spines and leaves. I have the links between both as unnumbered to that particular loopback. So then I have OSPF enabled to the loopback so they can discover and know each other. So then with that, I can establish BGP session between the loopbacks. So then with that, I can do EVPN and VXLAN. So I have an open fabric. If I replace this from one vendor to another, most of those features are agnostic and open. So I can just replace. If I have my zero-touch provisioning, it's broken, no problem. You pull out, you pull in a new one, and it goes through the process of I boot, I get the configuration, I do my callback, I'm ready again. Another use case is firewall and load balancer automation. The main thing is that I have a standard format. It can be a variable. It can be a CSV file that I parse. It can be an external system that I query. It doesn't matter. What matters is today when the application owners, they go and do configuration on cloud, they do not have all that fancy features that we have in the firewall device from different vendors. Well, my IPS is better than the other one. Yes, mine IDS is much faster, and all of that. All the application owner they care is, can my application connect to the database, and can I avoid that anyone external to that will not be able to connect to my database? That's what I care as an application guy. As a network guy, what I care is, should I enable or not my IPS, my IDS, and so on. So as an application guy, I have a standard format in the same way as I do when I'm describing rules for the cloud. I have source, I have destination, I have the protocol, I want to allow, I don't want to allow. And as a network guy who do the implementation, based on the different firewall that I have, I will enable or not the fancy features that they are able to deliver. So in the ASA, I will just, my implementation, this is my data model. This is my implementation as network guy. So I take this data model provided by a user, external system, the same, and I translate to the role that I will apply to ASA, that I will apply to Palo Alto, and so on and so forth. To IP tables. All good? Awake? And the use case here is for cloud connectivity. That, well, what is that actually? Well, when the guy from public cloud, he came in, he said that they are the best. I can get the cheapest thing from them. But 1 month after that, well, the other public cloud actually is cheaper than that one. How do I do? Because then now I have an application that will potentially be with piece in cloud 1, other piece in cloud 2, and the data is at home in my on-premises data center. And that's the joy of dark fiber, direct connect, and all of that. And then people come back and say, hey, your network stuff is really expensive. Only that link to that particular cloud cost me a lot of money. So the cloud connectivity here is basically for each particular tenant that I may have in the different clouds, I create a router, virtual router, in that particular VPC or in that particular project and so on, in the different clouds. I have a virtual instance on premises to provide the connectivity for that particular tenant. I do my VPN tunnel between them, I do my routing between them, so my application can communicate among different clouds and my on-premises data. Perhaps I may also apply some firewall here or in other place. Anyway, I'm not tied to that particular physical connectivity, and I can also expand thanks to automation to have routers and instances that are not the same for the different tenants. It can even be a RHEL. That's actually one of the roles that we'll deliver for this cloud VPN connectivity. You may have like a Juniper here, for whatever reason, a Cisco there, a RHEL here, or a RHEL everywhere, doesn't matter. And then we deploy and do the configuration to have all this peering and communication. And the last use case is ITSM automation or integration, where in this case, as an example, we have ServiceNow. And then in your ServiceNow, you may have a service catalog that applies to network, that consumes the automation that you did for tower. Or you may have something in the ticket, incident ticket, where the operator he can click, that the operator can click to do the troubleshooting, or someone can go and click to provision new network-related things. That's where having data in Git and in ServiceNow will combine together, because all this data, I don't expect that ServiceNow will create a pull request in your Git repo, but they will refer to all this information in their own CMDB. And that will combine with the configuration you have applied to group, and your automation will know what to do. So that's the big picture of the automation. You have developers, SMEs, operators that rely on this automated process to get data, specs, as we saw, and apply those to the different infrastructure components. Any question? No? So the quick thing that I had to show is in this particular repo here, which is my inventory, I'm using Travis, which is a platform to do continuous integration. So what I'm saying is that whatever pull request comes here, so whatever change someone wants to apply, it will trigger an automated process to validate and to test potentially that change. So the initial step is validate if the variables are properly defined, linting variable, validate that they are not breaking something. And after that, the other step could be I create a virtual environment, I apply the configurations to that virtual environment, and I run all the tests to validate that I'm not breaking what's working in production. So for example, for this one, is this one the right one? Don't remember anymore. It's this one. So this one, what I did is that I did create a change that I'll actually change my, simple example, SNMP community for read-only and read-write SNMP community. So when it runs, actually, when I did propose this change that can be tied to a change request, that can be tied to an issue or something, it runs, it triggers the validation process, here I'm using a public service. It could be whatever you have on premises as well. It's just to get the idea, basically. So it will trigger a process here in my cloud, in my CI thing, that will validate the variable values, that will validate if everything is fine in my data model, in my configuration that I want to push and apply to the device. If it happens, I have a green light here, which means, okay, it passed the test. So it increases the confidence, okay, it will work in production. And the next step is I take this change and I merge in my production environment. So then all the Thursday, Wednesday, I don't know, that particular source of information is taken and applied to my configuration, my device. So also here what I have is I have a tower instance. From where I have some jobs only for validation. That's why I'm calling this tower CI, which is different from my production tower instance. So basically in this tower CI, I consolidate all the tests, all the different activities that I have to do to validate my process and to validate the change I want to do. I can also create a workflow if for any particular reason I want to do multiple tests. For example, I want to do the base test, then I want to do a site one, which is a topology specific test. So instead of always creating my entire topology as virtual infrastructure, I can decouple. That's actually what we do most of the time. We have data center one, we have remote site one, we have spine, we have leaf. We decouple that, and we use that to build and create partial topologies against which we validate the change that we want to do. Is it? Anybody lost? Don't be shy. Ask. That's the time to do so. Yes?
I'm really interested in that validation of the variables passed to a role.
Mm-hmm.
I was just briefly looking at that module but couldn't find it.
Mm-hmm.
Can you explain a bit more?
Yeah, this particular model is being integrated as part of the network role. It's integrated as part of the network engine role, and this is released. So to use that model, you need to call the network engine role, or have the network engine as dependency to be able to use that model. But that is part of the implementation, right? That is when I'm executing. But before executing, I want to validate if my values or other things are fine. If there is no tabulation that's not right, if there is no missing definition for variables and all of that. So that's exactly what I'm doing. And I can even go beyond that. I do not have this in Tower yet, but I'm still working on it. I can also let me put this as well. As part of my validation, I guess it will be simpler to just mirror my screen. Hold on. Arrangement, mirror display. Okay, all good. All right. So it could be, oops, where is it? Yeah. I could also integrate as part of this something that validates some of my standards. Like here I'm validating as part of my test against my variables, because that goes beyond the spec. Because the spec would be, it's a list and it's defined. the validation is, I wanted to have the communities for read-only and read-write, which are not the same. That goes beyond the simple spec of I have a value and the value is that. I want to validate that for read-only, it's at least 10 characters long. For read-write, it's at least 15. That I have capitals and special characters for one and not for another, and all of this. So this is something that I can integrate as part of my test as well. To, for example, only using asserts, which is a standard thing from Ansible to validate and test. That I have my values defined. I have my read-only, which is a list. I have my read-write that's defined, it's a list. I want to validate that my SNMP read-only community is not also defined in my read-write. I want to validate that my read-only community has at least 10 characters long. It's ASCII. It has at least one number and one capital character. For my read-write, I want to validate that it's at least 15. That pretty much the same. It has lower and higher capital and at least one digit. So all these are things that I will validate when a change comes in. I could do that for VLANs. I could do that for validation that most of us will have VLANs groups or range that are for storage, that are for this, that are for that. I could use this also to validate that VLAN for storage in AS or whatever is not being used for application. And all this sort of validation that goes beyond, I want to have the configuration applied. And I can integrate this in my pipeline, in my process of change validation, which today we basically do this manually.
Victor?
Yes?
A question. So checking the spec file is only included in the networking modules?
So far, yes. We are smart guys. But I guess there are some plans to also have this as part of Ansible upstream. It's just that we don't like to wait. So we
I
didn't.
like this approach as well, to have a custom role that does the checking on your variables.
Yes. This is, you have two types of tests. You have the test that you do for the implementation, and you have tests that you do against data. So these tests here, I run against data inputs, which are will transform afterward in configuration when my implementation starts to use those. But I don't want to even start to deploy and try to configure something if my data is not good, or if my data is not properly in compliance with my policy. That do not replace compliance, because if I still allow people to connect and do CLI, this thing only ensures that what comes through this will be in compliance. But if I still have direct CLI access, perhaps someone did change something that is more configuration analysis than policy and enforcing that my policy is in place. I don't know if it's clear, the difference for everyone. So that's why I'm calling this policy. And I could have different things, for example, SPF. Whatever new values come to my OSPF implementation, I want to validate that the password is established. It has, I don't know how many characters, and all different validations that I want to add on top that are not really implementation, right? Implementation is the password defined. If it's defined good, I will do the configuration. It's more about policy, actually. Is the password in compliance with this size and all of that. So it's too much for, I don't know, 2 hours. Hopefully it was helpful. You're still awake, so that's good. Sorry for the guys that just start with Ansible. We covered some of the aspects about how you can do the baby steps, but based on the conversation, the question, it got really to the advanced topic. But we can talk afterwards if you want. Yes, Chris?
This validation is, of course, something which is good, but if you use Tower and you use forms, you would like to have the validation up front in the form. Is there a way, is there thought to implement this in some way?
The thing about forms is that there is no persistence for forms. Even if you ask for the user, what is the VLAN, what is the name, the VLAN ID, it will go directly to the device, but then you lost the reference. Because it will be in the device configuration, but it's not in your source of truth. So as part of the form, you should integrate actually to put that in your source of truth, and all the tests you run against your source of truth. It's a valid approach, but the only thing about that is that it will be lost. It will only appear in your backup.
Yes, well, the scenario in which I'm now working on is we have infoblox, we have ACI, and we want to make the deployment of servers easier for the data center guys. We want to give them a form, and they say, this is the application, this is the expected size of the application, so we can select the network, this kind of information, and then it puts the configuration in. So
yeah, but
it's not something which I want to keep in
yeah, but that's something that will go in your info blocks, because so that's your source of truth.
It will go into ACI.
That's your source of truth.
Yeah.
Getting the info blocks data as dynamic inventory that will merge with your other inventory data against which you run that policy enforcement. Otherwise, you can integrate that policy enforcement in your playbook that implement that data. For example, you have a playbook, create new blah blah. You call a role which is validate policy. You call a role which is implement or do the blah blah. And then it's just that you are not playing against the data, you are playing at the runtime. But still a valid way to do the validation. A recommendation is then that this validation will not live with the inventory anymore, but will live as a role by itself in their own repo, because it's not consumed only by the inventory, but also by your form implementation. Other questions? Yes.
So this is mainly about data validation, right?
Yes.
So the implementation and the actual playbook validation changes. How do we do that?
Is the next step here. This is only for data validation. The other thing that I have here are pipelines. So as part of my pipeline, I will do the creation of the virtual environment, deploy the configuration, and do other validations, which are, for example, is my peering OSPF up? If it's not, it failed in my test of OSPF test or something. So over time, yes, you will start to have a lot of tests, a lot of tasks to test, depending on how you do the implementation and how you test. But the idea is, whatever thing you change, you always have something to test that. That's the basic idea is, whatever you have a new data model, whatever you have something that you will change or you will consume in the implementation, you have a test associated with that. So that over time will allow you to speed up the process, the automation process, and also will increase your confidence that it will not break when you roll out in production. All right. Don't know if you. I guess you guys are hungry.
No more questions? Okay, thank you, Victor.
Thank you.
I hope you learned something today, this morning.